Good morning. Peter Klein, Chief Investment Officer, co-founder of Align Wealth, here with you today for a special discussion on the state of water here in the United States, around the world, and specifically and perhaps even in our neighborhood here on Long Island. But to round it out, we brought some experts to chat with us about this one particular pesky chemical known as PFAS. We'll get into it. But before we start, just a moment or two about Align Wealth. And we're a wealth management firm. We serve our clients as their fiduciaries. And as Chief Investment Officer, I've been focused on the water sector for a decade plus now. Fascinating set of economic circumstances, a great program of potential investments. It's a lot going on there. We have to unpack it. This is one piece of a larger piece on the water economics, as well as the infrastructure side, as well as the utility side. But before we get started, I'd like to welcome our guests today. Please say hello to Patty Wood and Paul Traffas. Patty, please tell us about yourself.
So I'm the founder and executive director of Grassroots Environmental Education. We are an environmental health nonprofit. We work nationally, although we are located here on Long Island and in Westchester County. We work on many issues that involve exposures to environmental toxins and focus on the most vulnerable in our society, which is pregnant women, young children, and people who have compromised immune systems. It gets us into all kinds of issues. As you can imagine, we are literally living in a chemical soup, and most of that also has implications for the water supply that we are so dependent on.
Let me thank you for your commitment and all of your good work. I know it's tireless, and sometimes you feel like you're on an island on your own, by yourself, and that's difficult sometimes. So, but thank you for your commitment and the good work that you and your team do. Paul, please tell. I know you're a water expert. Tell us a bit about yourself, please.
Okay. Seeing a need for purification of water back in 1983, mind you, I started the company, and along the way have gotten involved in a variety of treating chemicals, both with the EPA and the New York DEC. Years ago, it would be pesticide groups and then industrial solvents. And now we're dealing with more exotic chemicals like these PFAS type chemicals. So I've designed systems for decades now for the government, Superfund sites, remediating these contaminated areas. I've designed systems for IBM. I work at Brookhaven National Laboratory for 32 years. So thousands and thousands of homes dealing with both public water supplies and independent well water. Believe it or not,
So you're a fixer.
on Long Island, we still have a lot of independent wells.
Yeah, that's true.
Yeah.
So I would say you're a fixer. There are problems with respect to water, and
exactly.
you help fix it. Now that's not an easy task, and we'll get into it. But
Correct.
thank you for your decades-long service to this sector. I mean, let's face it, folks. There's no substitute for water. No matter what the price is, you're going to have to pay it. So there's economic implications to it, and it's safety, it's industry, it's biologic health. So all of these things go into why we're concerned and why we have been concerned with respect to the water sector. Now we're taking it a bit more on a capitalistic perspective with respect to investments, but if you think about it, if you're supporting a company that's doing good work in water and you're supporting it by investing in it, perhaps it therefore becomes more sustainable for the long term, so it could get the job done. So investors, be proud of the work that you do behind the scenes by investing and allocating your resources to companies that are fighting the fight and doing the heavy lifting. Patty, let me turn it to you. I mentioned it from the outset, this pesky chemical called PFAS. Perhaps you could start the conversation, because we are focused on that today. Perhaps you could start the conversation off by giving us a quick tutorial on what that is, and then I'll go to Paul.
Okay, well, I'm going to try to be quick, but this is not a quick topic. So PFAS is actually short for per and polyfluoroalkyl substances. They're chemicals in this class of more than 5,000, and they're found in thousands of consumer and industrial products. And examples are nonstick pans, for example, Teflon, which we are most familiar with as far as, pans, food packaging. This is also a huge category, from pizza boxes to takeout containers, from restaurants to plastic packaging, waterproof and stain-proof clothing, including workout gear, outerwear, carpets, upholstery fabrics designed to repel water, grease, and stains. These are enormously useful chemicals for industry and for manufacturers, which is why they are so widespread. They're also used in firefighting foam and on military bases and at commercial airports. We have found some real concentrations of PFAS here on Long Island in some of those locations. And then everyday use personal care products like dental floss, waterproof mascaras, eyeliners, foundations, liquid lipsticks, sunscreen, shampoos, shaving cream. These can all contain PFAS.
Ubiquitous. Everything we touch has it in there, it seems. It's
unless you are actively trying to avoid it, you are probably being exposed to it every single day. So, but
for years, we've been going on, and now what's happened?
So, well, recently researchers are warning of yet another and so far under-recognized source of this. And this is really important for Long Island and Long Island water because we drink from, 3 underground aquifers. But the other source that we're talking about here is common pesticides that are being used. So nearly 70% of all the pesticides introduced into the global market from 2015 to 2020 contain PFAS. So they don't break down easily. They can persist in your body and in the environment for literally hundreds of years due to this extraordinary chemical bond that they have. And as a result of their pervasiveness, they are known as forever chemicals. You may often see that if you're reading about PFAS, it'll say PFAS, the forever chemical. But they're more than 97% of the US population has PFAS in their bodies, and about 200 million Americans are drinking PFAS contaminated water right now. According to the CDC, this concentration of PFAS in drinking water presents one of the most seminal public health challenges for the next decades.
But
any questions so far?
In years past, it's been going on for so many decades. How do we square the circle that now all of a sudden the EPA is saying, hey, wait a minute, there's a problem? How does that work? I mean, why didn't this happen 30 years ago?
Well, because they weren't looking, and Paul can attest to that. I mean, they weren't testing for PFAS all those years ago. And so, there are long lists of chemicals out there that have potential, disastrous effects for human health and the environment that are still not on the list, right? For testing for our public water supplies. But PFAS has really taken a hold right now, and people are just looking at this very, very seriously.
Well, they should. So, right. So Paul, talk to us about what we do now that we have, a situation that we know is problematic. What does the water authority or local authorities, or perhaps a larger EPA national, what do we do about it?
It's a great question. So right now there are a few different technologies in removing these chemicals. Basically, the 3 methods would be carbon filtration, resin technology, and reverse osmosis. But let's break down, like Patty said, there are over 5,000 different variations of these PFAS, but we're just going to break them down into 2 categories just to keep this simple and easy. You have what they call long chain and then short chain of each of these groups. And these basically are carbon chain with some fluorine and sulfur and hydroxyl attached, and they come in all these different variations. So with that, The water utilities are trying to do the best they can. You don't want a $600 a month water bill either. However, with the carbon filtration, that works well with what we call these long chain PFAS chemicals. Those have mostly been, I guess, banned or outlawed, at least in this country. So whatever's in the ground has been in there for 50 years or so. But they are in the ground. They don't, like Patty said, they don't break down, so they are there. So the carbon will remove that if it's the proper type of select carbon. You just can't use any run-of-the-mill carbon. But it does a very poor job in removing what we call the short chain. The short chains are, these chemicals are still being manufactured by the tons. And they will be partially removed by the carbon. They're very soluble in water. They absorb through plant roots and typically go to the edible parts of the plant, believe it or not. So even if you're buying organic produce, that doesn't mean anything because the water supply may contain these chemicals. So with that, the resin technology, I would not get involved in that quite yet. It's still being researched. They say it can absorb some of these chemicals, but can is not my kind of word. Will is what I'm looking for.
And
reverse osmosis is indeed the best technology in removing both the long chain and the short chain versions of these chemicals. Now you're only going, excuse me?
Very energy intensive, correct?
Well, you're not going to do that for a whole house. It's just not going to happen. You can do that at your sink, at what they call a point of use application, and that works quite well. So, most of the townships are checking these chemicals now. They're probably installing carbon filters. A lot of towns have had carbon filters because they've had other organic chemicals. You can have competing chemicals in water. So now you're trying to remove trichloroethylene that might be there or some other group like that, and the PFAS. So, maintenance of this equipment is very, very important. So the carbon uses what we call an adsorption process. So carbon is naturally carbon. These PFAS chemicals are also carbon-based. So carbon has an affinity for carbon. So they get adsorbed, not absorbed like a sponge, but adhere. So they adhere to the carbon sites. And it's got, so much capacity. So unless you're monitoring this very carefully, like with my EPA jobs and that, we have multiple filters in series with test ports, and they will do testing before and after each set of filter. And as they break down, you're kind of rotating and changing these filters.
What sounds to me like this is a big job.
Oh yeah, no, this is monumental. That, they're going to fight this as long as they can, like they did with cigarettes for 50 years. Who pays the price? So with that, if you're relying on the water authority, they're going to maybe have their carbon filter, you'll deal with long chain. The short chain is the big problem right now because we're still manufacturing these things. They slip through the carbon, but at least you don't have to do your whole house, but for ingesting at least a good reverse osmosis. Now, with the reverse osmosis, mind you, there are virtually hundreds of these different brands of this equipment on the market. They're all going to do the same kind of job. With the new membrane technology, whether you're buying, X, Y, or Z, they're all going to be very good. Efficiency is another thing. So if somebody's buying a reverse osmosis, they want to look at the efficiency of that system, and it will be listed on the data. They should always look at the data and see what the efficiency is, because some of them can waste a tremendous amount of water, and you'll only know that by that efficiency rating.
And water that we can't really afford to waste any longer.
Yes, for instance, around here, we've got a lot of water. Arizona, California, Colorado, big problem. You can't be throwing 8 to 10 gallons of water down the drain to make 1 gallon of purified.
Not
So
good.
you can find there's not that many out there, but there is some extremely efficient systems out there that can put a 2-to-1 waste ratio. So it's very important to look for that.
That's very helpful, Paul. Thank you. Patty, so do you, in your conversations with everyday people and in organizations here on Long Island, do you come across this issue a lot? Is that something that's in your forefront? I mean, the PFAS?
There's no question that people are concerned about it. They don't as so many people don't quite know, how to pronounce it. Certainly they're not going to say per and polyfluoroalkyl substances, but PFAS is becoming a more well-known and feared water contaminant, and rightly so. I mean, although the manufacturers of PFAS, mostly DuPont and 3M, they marginalize the health effects. Research is really linking exposure to this through drinking water, but also through skin absorption, right? Because we are wearing it in some cases, we are breathing it in some cases. But studies of the best known and the most commonly used PFAS substances are PFOA and PFOS. And they show link to kidney and testicular cancer, endocrine disruption, reproductive developmental effects, liver toxicity. I mean, it goes on and on and on. So we are concerned, and the public is becoming more concerned because there are some serious health problems associated. And the fact is that you don't need to be exposed to very much. And we were surprised last week that the Environmental Protection Agency came out and they proposed new lifetime advisories, health advisories for PFAS in drinking water. And they really changed the equation. I mean, big time. I mean, they changed it, like, for instance, for PFOA, they went to 0.004 parts per trillion. 0.004 parts per trillion.
Above that, that's where your problem occurred?
Right, and 0.02 parts per trillion for PFOS, That's previously, the EPA had set those limits at 70 parts per trillion.
Wow.
Okay, so this is setting off alarm bells, for both consumers and regulators. And it really demonstrates that we have to move much faster to dramatically reduce these exposures, because they are toxic to human health at extremely low levels. And Paul can attest to that.
That's wild.
Yeah, so
that's a major difference.
So to keep in mind with these chemicals, to understand it better, they are what we consider bioaccumulating in your body,
because they never go away.
Yeah.
Hence
Now,
the word
so
forever.
Chemicals, not just in the environment, but forever chemicals in our bodies.
And they tend to accumulate in the protein bases of your body, and also in organs that have the most blood flow.
Mm-hmm.
Lovely.
So years ago, there were many chemicals that would accumulate in the fatty parts of your body, but this is going directly in protein, which is scary, because if you think about it, what is your brain?
Building blocks of life are proteins.
So they're not even really sure yet where to take this. If you read EPA information and that, the data is going to take years to accumulate.
They're saying that they might set, an enforceable drinking water standard by the end of 2023 for just those 2 PFAS chemicals, just PFOA and PFOS. And they need to.
And if they do that, and when they do that, that means that there's going to be a heightened scrutiny on various water authorities and systems to make sure that they're in compliance.
Right, and that's going to be money, and you're going to have water systems who are going to say, we don't have the resource.
They're going to raise their rates. They're going to raise it. I often said, 15 years ago, I said, your cable or your telephone bill is going to go down, and your water is going to go up. And I think we're getting there. Let me wind this up by asking if there is a playbook that we could take off the shelf that gives us some sense to what we're looking at. Is it potentially the story of the dry cleaning chemical? What was it called? PERC?
Yeah, perchloroethylene, right.
Is that a similar situation, Paul?
No, very different. You know, those organic chemicals were fairly easily removed by basic carbon filtration. This is a league in its own. And those organic chemicals could break down in nature. If they were in surface water, just the ultraviolet ray from the sun and that exposure would what we call volatilize out and just kind of break down. Now, this is hardcore stuff. This is the toughest thing we've ever had to deal with. Implications are enormous for the next 100 years.
Right.
And they're just seeing the tip of the iceberg. For instance, up in Hoosick Falls, they didn't even realize this stuff was in the water for decades until a private individual in the town realized there was a very high incident of exotic cancers. And it's a very bedroom community. It's a beautiful area. He should have went to Las Vegas that day, but instead he found one of the 2 laboratories at the time, this is 4 years ago, that could even test for this series of chemicals. He sent an analysis and came back with this positive result of PFAS. He didn't know what it was. He brought it to even the utility in the town. They didn't test for it. The rest was a nightmare. It became a Superfund site. This was when they called me to come and help them out up there. It was like a military installation. They assigned an officer to me with a bulletproof vest and weaponry. Yeah,
Wow.
yeah, yeah.
Because people were against it?
No, that's what I thought. I thought, you go ring the bell at the house with the vest on. No, because it was part of the national security of the country. So anytime there's a disaster,
oh wow,
they called in. So I had that and a DEC officer with me, and then we would go in and install all this equipment. These people were panicking, like your value of your house is worthless today.
Yeah, that's what of course that's it. Yeah. And if you think about it, most Americans, their home is their #1 investment.
That's right.
And then the big problem with this is now you've put in these filters, unlike a reverse osmosis that tends to reject that impurity. So it kind of goes down the drain. You're kind of putting it back down where it came from, but at least it's, not here. The carbon filtration is a nightmare because now it is a toxic waste.
Yeah, what do you do with it?
What do you do with it?
Right.
You can't burn it. I didn't get a straight answer from them because they didn't know.
Yeah.
Nobody was really treating this stuff.
Right.
How do you want to say something? We're wrapping up.
Yeah,
here.
I just wanted to say that, 2 things that the perk that you were talking about, which is unfortunately still being used and is still a water contaminant on Long Island, that is actually a lipophilic chemical, right? So that actually gets stored in fatty tissue, as opposed to what Paul was talking about, which is that, this chemical gets stored in protein, which is, but that in itself is a game changer.
Well, we don't want it in our body at all, but you certainly don't want it in protein.
Exactly. But then, and I also wanted to mention that there are 2 films that were made about PFAS, and the fact that the industries knew, 3M and DuPont knew about this incredibly strong bond and the persistence of this chemical in the environment. And so one of them is called The Devil We Know, and the other is Dark Waters. And if people want to just watch those movies, you can get a whole sense of how this happened, how the industry was able to convince the government regulators, blah, blah, blah. And that's still going on today, even with this knowledge about this catastrophic, situation that we're in now.
Public health concern,
supplies. Oh, absolutely. This is a public health concern of enormous proportion.
Well, I want to thank you both for the fight you're fighting and the dedication you have and the work that you've been doing. It means a great deal to us here on Long Island and hopefully around the country and the world. We got work ahead of us, folks, and I thank you for briefing us on this particular situation. I look forward to further conversations focused around the water sector and the water industry. Thanks again for all your hard work in this area. Appreciate it.
Thank you, Peter.
Thanks.